seriously, this type of device is going to increase safety in the home.
Adding some scientific innovation to cooking.
Yeah. This is literally like the proof of concept that we're trying to show people, right? Is that you can set it and forget it. Welcome to another episode of the BYU Tech Transfer Podcast. Today we have James Monson with us. He's going to talk us through the anti-boilover pot and how it works, kind of the development that's gone into it, and then we'll talk about some of the opportunities for licensing and entrepreneurial ventures with it. Mm-hmm. So James, tell us a little bit about this, and I know we're starting with a demonstration, so maybe you can talk through it and then get the demonstration going.
Okay, yeah, so just a brief, I guess, introduction is that this came from a Capstone project from the Mechanical Engineering Department. Essentially, it's a pot that uses a thermocouple in order to read the current temperature of the water, and then it sends that data to a servo that's connected to the dial of the burner, and then it will adjust the burner according to whether the water is boiling, whether it's getting too hot. Essentially, it continuously takes temperature readings in order to find a boil point, and then once it finds that boiling point, it will adjust the temperature in order to prevent it from boiling over or getting too hot. So it's a pretty nifty device that will be very helpful for cooking applications.
Yeah. So while he's kind of getting the demonstration set up, what I've thought about with this device specifically is I'm sure everybody has had that experience where you're cooking a pot of pasta or, you got some vegetables boiling, potatoes, whatever it might be, and you turn around for 3 seconds to go do something that you forgot, switch the light switch off or the baby cries, and so you walk over, whatever's happening, and you turn back around and it's boiled over and you've got this giant mess, and then you're running over, frantic, trying to turn it back down. Because you still need it to be hot, right? You don't want to turn it off or take it off the burner because then you're just delaying dinner. But such a frustrating experience, but one that's very relatable to all of us. So with this device, the idea would be that you could put on a cold pot of water with whatever it is that you're boiling inside. You could then set it to boil, and it would bring it up to a boil as quickly as it can, and then reduce that temperature so that you don't have that boilover effect that happens and has happened to all of us. So James here, he's going to get this going, and you should see the light turn on the burner here, and then it'll start to heat up, and then before it actually starts to boil, we'll turn it off just to demonstrate the functionality of the device itself.
So right now I've set up how it's working. I've pulled up there's a web GUI that connects to the microcontrollers, and so I can give it a command. I put in a time value for how long I want it to cook, and then when I press start, the servo will move and it will turn the burner on. So I've put in a time value on my computer in order to tell the boilover pot how long I want it to cook for. And so after I press start, it will turn the servo on and then will cause the burner to start cooking.
Yeah. And if you couldn't see that on the camera, the servo just turned on. You might have been able to hear it. The light came on, and that's max temperature setting, right? As high as it'll go.
It starts as high.
Starts heating it up as quickly as it can.
Mm-hmm. Yeah. And then you can't see this, but on my screen it will also display the current temperature that it's at. So that way, as you're cooking, if you ever are curious about what the temperature's at or if it's getting close to a boiling point, it will notify you as to, with a temperature gauge, kind of how close to 100 degrees Celsius it would be.
So again, if I was a user, right, and I had a big pot of water and I knew it was going to take maybe a couple minutes to bring that to a boil, I could put that on, right, and then if you wanted to, you could walk away. You could have this app on your phone. You could be watching the temperature rise, and then as it gets close to the temperature, let's say you're boiling eggs and want to drop it in at that boiling point, you could then walk back. It would boil. You could see it, getting there. Okay, now it's boiling. Drop in your eggs, set the timer, walk away, right?
Yeah.
And you're good to go.
Exactly. And so I'm using a laptop here, but the app totally works on your phone as well. And so you can pull it up on your phone, just like Bennett was saying, and use it remotely to just monitor what temperature it's at.
Very nice. So while this is heating up, I don't think we're going to take it to a full boil, but at any time when you want to turn it off, just go ahead and do that, but let us know. But as that's heating up, maybe tell us about the development of the device itself, your work on the project, maybe how the tech, what state the tech was in when it was handed off to you, just generally your work here.
Yeah. So when we first got the tech from the Capstone team, it was a pretty much mostly developed product. They had a couple prototypes that had been tested. Some of them were actually already broken, like they had gotten water damaged or something like that. So we took their existing prototypes and then we made our own prototypes based off of those, essentially.
Right.
So what we have here is stuff that we've all made completely ourselves. We redesigned their CAD files in order to make what we thought was a more, I guess, easy to hold and also easy to assemble and deassemble for testing.
Yep.
And then also the lid, this lid piece right here is also something that we cut ourselves in order to have the knob attached to.
Yeah. And in product design, this is a very common process, right? Where you might have somebody who's created maybe the initial concept and prototype, but then you'll iterate on that and you'll iterate on it over and over again until you kind of hone in to this more polished, ready for commercial production device, wouldn't you say?
Yeah, exactly.
Okay.
And on that iteration, they actually left some notes about stuff that they wanted to do for next iteration. So that's what we kind of base our iterations off of.
Gotcha.
We added an on-off switch in order for it to, before there was no on-off switch, it was just on indefinitely.
Right.
And then we also, on the web GUI, we added a temperature sensor. That was something that wasn't there before. So there's just a couple functionality bonuses that we add in order to make it a more complete product that would be closer to be marketable and sellable.
Okay, fantastic. And give us an update. Like, I'm starting to see a few little bubbles form here. What's our temperature at?
Yes. So we've gone up to 35. Generally, it's a room temperature around 20-ish, but it's already gone up 15 degrees.
Nice.
And it just keeps going up. So.
Okay, awesome. So what other challenges did you have in the development? I mean, like you said, the Capstone team did a lot of that initial heavy lifting. So you guys were mostly polishing and refining. What kind of, I don't know, what would you call it, skills did you hone in the development of this tech? You know, I think that's one great thing about engineering is that even if you've done, prototype design and engineering for 50 years, every new project has something that's a little bit different that you have to take on. So what was an interesting challenge with this? Yeah,
I think that the hardest challenge for this was definitely interfacing with we're using ESP32 microcontrollers that have Wi-Fi capability. That's actually how they're talking to one another, is one is sending data to the other over Wi-Fi. That was something I never really used before. I had experience with Arduino microcontrollers, but we never were using, wireless connections. It was always just wired connections from device to sensor.
Right.
And so it was a bit of a process and lots of Google in order to figure out what the best way to have the ESP32 boards connect to one another and then have them, just connect properly and send the right data. And then another thing as well was developing the web GUI. That me and the other intern, he's more software savvy, so he worked a lot on the web GUI to improve that. But we worked together a lot to develop the software a little bit in order for the algorithm that they had developed to test the temperature, to be able to make that a little bit more nuanced and have more functionality.
Okay.
So
very nice. And then taking maybe a step back from an entrepreneurial perspective, maybe let's get your thoughts on, let's say you're an entrepreneur, you already are, right? But let's say that you were looking to pick up an Internet of Things, a connected type device, right? We have this device. I don't know, maybe I'll test your knowledge here. What would be your kind of path to acquiring this from the BYU Tech Transfer?
Well, I would definitely get in contact with the Tech Transfer and express my interest in having a license of the technology in order to take it to market and sell it. And I believe that there's a process of, getting that license and then how much money goes along with that.
Yeah, and this is one thing that's really great about BYU Tech Transfer is that we understand that students, right, even entrepreneurial-minded students, sometimes they don't have large sums of capital that they're just waiting to deploy into the next venture, right? Sometimes everything's cash strapped, you're really struggling to make ends meet, going to school, eating, and then starting a project like this can maybe seem daunting.
Yes.
But what we really want to do is connect students with the right resources, right? So the first resource is the actual device and the technology itself. So we cover the patenting costs associated with it. We hand off all of the design files, the software. We can put you in contact with James and the other intern who can walk you through kind of what they've done in the development, explain the software side to you, explain the web GUI, steps that are needed to take this from maybe a web GUI into an actual app on your phone.
Yeah.
Right? We try to connect all those dots for you on the actual tech side. So from a startup perspective, you're not coming in with just an idea, right? You're actually coming in with hard tech that has been developed. You could run, a couple hundred of these prototypes if you really wanted to as proof of concept and get some initial sales going. Then what we want to do is we want to connect you with other resources on campus to make the opportunity that the tech presents into an actual reality. So we want to connect you with the Rollins Center where you can get validation grants and traction grants. The combination of those grants is up to about $27,000, right? We want to connect you with the competitions that are going on campus. So you've got the Student Innovator of the Year competition by the Mechanical Engineering Department. And then we have a competition that we host at the Tech Transfer Office where you license technologies and you compete for some sort of cash award. We're still working through the details, right? But that's another great opportunity and great resource for you to take these concepts and technology and spin it off into a company with enough resources to actually make that a profitable company. And then to James' point about the consideration that comes back to BYU, again, we want to be flexible, understanding that you're a startup, right? That most of the cash that you have on hand is going to go directly into the startup. And so we want to negotiate terms that are mutually beneficial. Because if you're not successful with the technology, then we're not going to be successful in our commercialization efforts and actually funneling some of those royalties back into BYU and into the research that goes on here. So as a student, does all of that make sense? Do you have any questions about kind of what that process might look like?
No, I don't think so. I think that what is probably most interesting is to see like what the technology that is available to make a startup out of. I think that's like, I don't know, seems very interesting to look through. And I mean, I'm sure there's plenty of stuff we can just take and run with. So
there's definitely different levels, right? So technology readiness levels, right, from 1 to maybe 9, where 1 is conceptual research, right? We do have those types of technologies available, but typically the capital needed to spin those off into a company a little bit more, right? A little bit more labor intensive. Timeline to that first dollar is a little bit more prolonged, right? Then we have technologies like this, which are packaged up,
pretty close to
super close, right? From what you've seen here, how much additional development do you feel would need to go into this product before it'd be ready for the market?
Yeah, I mean, I think that if you had a really nice 3D printer or just injection molding, like you could get a ton of easy, like well-developed housings for all this stuff, and then maybe change the microcontroller so it's a little bit smaller. I mean, there's just small changes that would just make this look like a perfect product and just ready for use. So
but the detail there that I want to point out is small changes, right? You're not reinventing the wheel. You don't have years of development that needs to go in to prove out the technology and make sure that everything's working. It's find manufacturers. It's start scaling, maybe some tweaks to the design for manufacturability. But again, small tweaks that make it maybe a little bit more functional or a little bit more polished for that end consumer type product.
Exactly. Yeah.
Very nice. Well, give us an update. Where are we at?
Yeah, actually, if anyone noticed that the burner did turn off, it's not because it broke. It's just because I only put in 6 minutes on the timer, and it's been 6 minutes.
Well, there you go.
But this
is literally like the proof of concept that we're trying to show people, right? Is that you can set it and forget it and say that, again, like you were at home. It won't
actually just like burn your whole house down.
Exactly, right? Like we got busy talking about the device itself and the opportunities. Kind of forgot that it was going. I didn't even realize that it had turned off, but it turned off because you only gave it 6 minutes.
Exactly.
So again, if you're at home making dinner, right, or doing something, okay, so quick story, right? When I was younger, I remember putting a pot on to boil, turning it on, and then completely forgetting about it, right?
That's
and
like
walking away,
all the time.
right? And then you come back and there's like no water or barely any water in it, and you feel not smart, right? Kind of like an idiot for letting that happen. Seriously, this type of device is going to increase safety in the home. It's going to mitigate the effects of kind of that forgetfulness, or, you know, you get pulled away to something, some emergency happens and you have to step out. Now you don't have to worry, right? Turn it off from your phone, or if you put a timer on it, it'll just turn off automatically. Super cool. So what other kind of uses do you see for this technology other than specifically for the anti-boilover pot? Because this could be a jumping off point for additional Internet of Things. And for those who don't know what that means, that's basically just connected devices, right? So like your smart vacuum, your smart TV, your smart thermostat, all those types of things would be considered IoT or Internet of Things types of devices. So this, again, thinking as an entrepreneur, if I were to pick this up, I would have the ability to control devices remotely from my phone with temperature reading feedback and then servo control for the dial here, right? So what are maybe some other applications of that type of technology that you might be able to utilize as an entrepreneur?
Yeah, that's a good question. I don't think I've really had, or haven't had a chance to think about that. I mean...
Well, let me tell you one that I'm thinking of, and you can tell me what you think. So the ability, so what I love about this is that you don't have to do a big retrofit onto your oven for this to work, right? So the pot lid goes straight on top of your favorite pot. The servo connects into your dial, right? So you would pull off the large dial, you would connect this in and now have an automatic dial. And what I could see this doing is you could do something similar with like a light switch, right? Where maybe you take off the faceplate and then you have a separate faceplate that goes on and you could turn on your lights. And I know that they already have some of these available on the market, but if you wanted to step into that space and compete, you would start with a product like this, which is completely separate for anything else that I've seen out on the market. And then you could expand that into other devices and utilizations in the home, right? Utilizing and leveraging the technology that you already have available, because you wouldn't have to figure out the web app and the controls of the servo and the hardware associated with it and the software associated. You would literally just have to change up a little bit of the hardware for the connectivity of whatever it is that you wanted to control. So I was thinking light switches specifically. Anything else that you can think of in the home?
Maybe one possible idea I'm thinking of, it's also cooking related, is a remote thermometer for meat in a way.
Okay.
So if someone's cooking turkey or chicken or something in the oven and they don't have to go through the hassle of taking it out and then sticking the thermometer and seeing how warm it is with something like this, that they could just stick it into the oven and have it like pierce into the meat and just have it sit there. And then it will constantly be sending like the internal temperature of the meat to the computer.
Well, and there's lots of like dishes that you have to cook, like maybe it's like your turkey at 350, right? Exactly. And then you want to pull it out and test the temperature, and then when it's done cooking, you want to put it back in at like 400 or 500 to really get like a crispy skin, right? And so this could be something where it does that automatically,
because it's connected to the oven.
Connects to the oven, so you get that internal temperature. Once it hits, I don't know what the temperature is, but safe cooking temperature for turkey or whatever it is that you're doing, it then turns the oven up and then holds it at a specific temperature for a period of time. Or related, right, but slightly different, what about frying things in oil, right, like a fish fry? So you could do the same thing where you have this gauge that's testing the temperature of the oil itself, and then maybe a gauge in the fish, maybe not, right? Maybe that's not relevant. I don't do a lot of fish frying, but you could hold that oil at a very specific temperature, because this, you could set that temperature at 40 degrees Celsius, 100 degrees Celsius, right? Whatever, or Fahrenheit, the equivalent. But you could say, okay, for the fish that I'm looking for, the ideal temperature is going to be X. I set it at X. It brings it up to temperature, sends me a notification on my phone saying oil is ready. Right? I take my fish, I drop it in. That's going to drop the temperature of the oil. So it increases the heat, right, to bring it back up to temperature quickly. But then as you start approaching, it brings your heat back down. So basically, it turns you into a master chef without ever having to, spend years and years trying to figure out exactly how do I control this temperature. You just say, oh, this is the temperature that I want, set it, you're off, ready to go.
Adding some scientific innovation to cooking.
Yeah, I like it. So it's still very much cooking related, but I could see both of those examples as being relevant and helpful in your home. And
I'm sure this is already all over like the thermodynamic like industry and stuff, but just having something that's reading temperature in order to like have a control over some actuator, I mean, that's essentially what's happening here. So
well, and that feedback loop, right? Because if you don't have the feedback loop, then somebody has to stand there and manually make decisions about, do I turn the temperature input up or do I turn it down? And again, I'm a terrible cook, but this happens all the time, right? Where I'll see something, or if the pot boils over, I overreact, I turn it way down, right? Turn around again because I get distracted cooking, apparently. I'm not paying enough attention. But then I turn around and I turn back and it's not boiling anymore, right? Or it's like way colder than it should be, so now I turn it back up, and you ruin the dish, you ruin whatever you're doing. You spend all this time playing around with it when you could have just set it, forget it, and let it do its thing.
It's true.
Very nice. Okay. Well, as always, the technology that we feature here is available for license, so feel free to reach out if you have additional questions about the technology itself, or if you want to walk through that licensing process. This is just one of many, so if you're interested in other, aspects of research that are going on at BYU, again, reach out. We can walk you through the process, and we want you to be successful. We want to connect you with those resources on campus that are available to students and entrepreneurs to really help facilitate your journey and give you the best possible chance at success. So we really appreciate James for being here today, kind of talking through the device itself and all the work that goes into making these types of things. Come in here, pick up this tech, spin it off into your own company, and take advantage of the work that's being done here. So Thanks again, James, and I appreciate you being on.